Introductory activity. This activity name What's in the Glass. Students, please look carefully at the two glasses in front of the class or on your screen. One glass contains a clear salt solution, while the other has a sand-water mixture. Take a moment to observe them. On your one-fourth sheet of paper, write down the differences you notice and answer this question. Are these materials the same or different? Why? You have 5 minutes to answer. Time's up. Class, let's check your answers together. For the first glass, what did you notice? Correct. The salt solution looks clear. You can see that salt anymore because it has dissolved completely in the water. How about the second glass? Right again. The sand-water mixture looks cloudy and the sand settles over time because it does not dissolve in water. So, are these materials the same or different? Great answer. They are different because salt dissolves and forms a clear solution, while sand does not dissolve and remains visible. Very good observation, students. Give yourselves a round of applause. We have our activity in 15 minutes. Group activity. Classify the samples. Now, class, you will work in groups. On your table are several materials: sugar, salt, water, sand, iron fillings, salt water, and the sand water mixture. Your task is to observe each sample carefully. Check how each one looks, feels its texture if allowed, and talk about whether the material looks uniform or not uniform. After that, try mixing some of the materials to see if anything changes. Does it dissolve? Does it settle? Does it stay the same? Record all your observation on the worksheet provided. You have 15 minutes. Collaborate well with your group members. All right, everyone, time's up. Let's talk about your findings. For sugar and salt, what did you observe? Exactly, both are fine. White solids and look uniform. Great observations. How about sand and iron fillings? Yes, you notice the coarse texture and that the particles are visible. Excellent eye for detail. What did you find when you checked salt water? Correct. It's clear and uniform because the salt dissolves completely. And how about the sand water mixture? Right again, it's non uniform, and the sand settles at the bottom. Impressive noticing. You all work really well in your groups. I can see that you discuss, explore, and observe carefully. Fantastic teamwork. In this application, you have only 20 minutes. This activity name Classify and Justify Matter Samples. To test how well you understood our lesson, let's have another activity. On your one whole sheet of paper, classify the following real-life items based on what you've learned today. Decide whether each item is a pure substance or a mixture, and identify whether it is homogeneous or heterogeneous if it is a mixture. So the items to classify: first, coffee; second, air; third, soft drinks; four, mineral water; five, cooking oil; six, salad. After classifying each item, make sure to justify your answers. Explain why you think each item is a pure substance or a mixture. Use clues like appearance, uniformity, and the number of components. For your second task, create a comparison table with two columns, one for pure substances and one for mixtures. List the examples under the correct category and briefly explain the difference using the properties we discussed. You will be given 20 minutes for this activity. Work carefully and think like real scientists.
All right, class. So we are done for our activity. So now let's begin your understanding based on the activity. Okay, ready? So let's begin. So first question. Which materials show the same properties throughout? Okay, anyone? Anyone from the class? Okay, very good observation. Sugar, salt, and water look the same all the way through because they are uniform and made just one kind of substance. So that's why nga, if i-look nimo nga to ang activity ganina, kay ang sugar ug salt, since na-mix na sila kay more tag nagtulok sa water. Kay ang sugar ug salt, when it's mixed with water man jud, kay mo uniform siya sa water kay mo melt man ang sugar ug salt. So that's why nga all throughout sa atong activity, so atong tan-awon ang sugar ug salt, it would still look the same because na-melt man siya. So it's all throughout more siya same properties ra. So okay. Okay. Next question. Which materials contain more than one component? So yes, okay, exactly. Very good. Salt water, sand, water mixture, and even a mix of sand and iron fillings. It contains two or more materials combined together. So, that's why nga, kanang, if i-mix man gud nimo, unlike sa salt o sa kanang water or katong sugar o water ganina, mo, ano siya ay, mo, all throughout, same properties ra sila. So, unlike sa kanang sand o water, kung imo siyang i-mix, di ba, makita na to nga na duha ka components or more than one components iya. Kay dili man mo melt ang sand kung i-mix nato siya sa water. So that's why nga atong nakita ganina sa atong activity nga there are actually more than one component. Okay, this will be for our last question. So anyone? Okay. What makes a mixture different from a pure substance? So may nakalahi sa mixture sa pure substance? May nakalahi niya? Okay, very good. So, a mixture is made up of two or more substances na physically combined siya. And you can only see or you can usually see or separate its parts. Unlike sa pure substance, it has only one kind of material. So, it stays uniform throughout. So, ang kalahian nila kay ang mixture, makita nimo nga naa siya two or more substances nga gi-combine. And also pod makita nimo nga kanang naabay na nalahi o unsa na siya nalahi. Okay, there are actually two or more substances. And unlike sa pure substance, okay, kung i-mix nimo siya, there is only one kind of material, so it stays uniform throughout sa process. So, okay. So, since we are finished, everyone, so very good. So, your explanation shows that you really understand sa itong activity. Ano may idea? So, you have an idea what is our topic all about for today. So, okay. Our topic for today is all about distinguishing mixtures from substance based on the set of properties. So, like we did ganina nga natagipang mix-mix nga kanang substances, one, two or more substances, kung ma-distinguish ba nato siya sa ma-distinguish ba nato siya or it only has one or more component or makita nato siya in uniform form. So, okay. So a mixture is a physical combination of two or more substances. So the components of a mixture which could either be solid, liquid, or gaseous phases. It can be any of the proportion. So for example, when we say mixture, dili ta name sa usa ka substance nga mixture ni siya if it's only combines one substance siya. So it can be called as mixture if naa siya combination between two or more substances. For example, there's one substance na imo na siyang i-combine, it is called mixture. So mo na siya. So one of the components sa mixture, it could be either between mixture or combination between solid or some mga solid like mga tangible things, right? Okay, for example, stones, gravel. Okay, then next we could also have liquid, so water. Water is the representation of liquid. So pwede na makakuan og mixture between sa solid, liquid, and also gaseous phase or mga gases like the air itself, oxygen, carbon dioxide, nitrogen. So that's why. So here are the followings that are some of the properties and characteristics of mixtures. So, for example, when we say components, so what do you mean by components? When we say component, it is saying its properties after combining them. For example, when we say components, kay mo na ni siya ang result between sa two combination nga sa duha ka substances. Like for example, na siya usa ka properties niya na po'y usa ka properties nga imong gi-combine. So after nimo makombine ni siya, this is called components. Okay, for example, salt water or saltwater mixture. So the salty taste identifies the salt as one of the components of the mixture. So, kung i-mix na to ang salt of water, so ang taste gid niya kay salty din siya. But if imo siyang i-look or imo tan-awon ang mixture between sa salt of water, more siya guwan. It's like water jud siya. Kay more siya guwan ang components, pero kung ma-identify nimo siya nga duha siya ka components ang gi-combine kung imong tilawan. Kay makian man dito nimo, ma-taste man nimo dito nga salty siya. So dito nimo makita nga there are more than one components sa usa ka mixture nga imong gigamit. Kung imo siyang look ra nimo siya or imo siyang itan-awon, like water siya, a glass of water. Pero kung imo siyang tilawan, na siya combination kay tungod sa iyang taste. Okay, next example, we have the sand and gravel. So, sand and gravel mixture, both components can be identified. So, kani siya, this can also be called mixture. But, ang kalahian sa sand o gravel sa mixture sa sand o gravel sa salt of water. Kay kung ang sand o gravel imo siyang i-mix, kay both components imo siyang ma-identify because dili man sila ma-mix together. Or this could be called I will further explain later. So ma-explain ni siya kung sa'y tawag ani niya. So ma-identify mo nga na siya duha ka components nga gi-mix. Unlike sa salt of water, ma-identify nimo siya nga, ideally nimo siya ma-identify dahil nga duha ka components unless imo siyang i-taste. Okay. So next, we have the chemical system. So what do you mean by actually, there are two types of chemical system. It can be both homogeneous and heterogeneous. So mana ni akong giingan ganina. So when we say homogeneous, it is one phase uniform in appearance. So like the example earlier, katong salt of water, kung makita nimo siya nga in uniform siya, even though i-mix nimo siya, it is called homogeneous system. For example, salt and water or the salt water mixture. Like in a glass of water, ang salt of water imo siyang isagol, like ma-mix siya in uniform, in one phase siya or naka-uniform siya. So, may siya gitawag yung homogeneous system. And another example, it could be a sugar and water. So, kung sugar or water mixture siya, kung i-mix nimo ang sugar or water, one phase ra siya niya, uniform ra yung appearance. Matawag ang homogeneous system, matawag ni siya homogeneous if one phase uniform in appearance ra siya. So next, let's move forward to heterogeneous system. For the word itself, hetero means meaning or two or more observable phases. So kani siya, if ang homogeneous system one phase uniform in appearance siya, ang heterogeneous system, it contains two or more observable phases. So ma-observe nimo nga naay duha two or more substance nga gimix. For example, we have the sand and gravel. So ang sand and gravel mixture, makita nimo or ma-observe nimo two or more substances nga gimix. So ma-identify nimo nga sand ni siya o gravel. So kani siya gitawag ni siya og heterogeneous system. If you see two or more observable phases with between sa usa ka mixture, gitawag na siya hetero. Only one phase ra siya or uniform, gitawag na siya homogeneous. So another example for hetero, we have the sand and water. So sand and water mixture. So kani siya. So between the sand of water mixture, so ma-observe na to nga there are two or more substances nga gi-combine or gi-mix. So ang sand of water, like very visible kayo siya. So ma-identify din nato nga duha day ka substance. So gitawag ni siya hetero. If maka-observe ka nga two or more phases or kanang mixture ang gigamit niya, gitawag ni siya hetero. Okay, another example, we have the oil and water mixture. So in between sa oil and water mixture, di ba? Ang oil mulahi siya sa water, di ba? If imo siyang i-mix. So ma-identify nimo siya or ma-observe nga there are two or more observable phases nga naa sa usa ka mixture. So makita nimo nga naay oil, naay water. Itawag na siya heterogeneous system. One of the simple way nga ma-differentiate ang homogeneous system ug hetero, ang homogeneous system one phase uniform ra siya. Kung mo siyang tanaw, uniform in appearance siya, but when we say heterogeneous, there are two or more observable phases nga ma-differentiate nimo sa. So next, we will tackle all about the boiling point. So, boiling point. So, ma-measure ang boiling point, it varies on the mixture. The boiling point of mixture differs while the boiling point of the substances is fixed. For example, pure water boils at 100 degrees Celsius. So, if a water added with salt, it boils at 100 degrees Celsius. So, kani siya. Sa boiling point, there siya, nagmatter siya sa usa ka mixture. So, we all know naman no nga, if ang mag-boil tag water, pure water siya without mixture, so it could be 100 degrees Celsius. Pero if mo add kag another components or another mixture, which is, it could be salt. So, if i-mix nimo ang water ug ang salt, so mo boil siya around 102 degrees Celsius. So, mixture greatly affects boiling point. It could change. Okay. If ang usa ka substance, okay, in terms of boiling point, sa ka substance, fixed na siya nga 100 degrees Celsius. Pero if mo add kag another substance, di nga murag mo change. Dili, mo change na yung boiling status, which is, katong gingan dyan earlier, 100 degrees Celsius na siya. So, mixtures greatly affect the boiling point. Okay. So, next we have, actually, do you know that mixtures can be separated by a physical process? So, there are different ways na makaseparate ka sa mixtures. Now, next, we will tackle all about decantation. So, decantation, it is the particles of the mixtures are allowed to settle down and less dense particles are poured off. When we say decantation, if ang duha ka mixtures nimo, or ang particles of mixtures nimo, ilaw nimo siya settle down, so ang less dense particles niya kay dili siya ma-poured off tanan. For example, to make it more clear, I provide examples. So we have the cooking oil and water. So cooking oil is less dense, hence it floats in water and can be poured off. So kung imo siyang ipa-settle down, ang cooking oil ug water, di ba ma-segregate siya? Float ang cooking oil sa water. Pero na siya tendency nga it can be poured off. So next, another example, we have the rice grain in water. So when you are rice washing can be poured off. So if dili nimo is pa-settle down ang rice or ang rice grain, may tendency nga mayabo siya tanan. So but if you use decantation or if mo siyang ipa-settle down ay ka mo poured off, so dili siya ma-wash off ang rice. So, the same with the cooking oil water. If mo siyang ipa-settle down, like mo float ang cooking oil sa water. Fine siya. So, muna siya kalahian. Ang decantation, it is the particles of mixture that allowed to settle down and less dense and particles are poured off. So, next, we have the distillation. So, distillation, it involves the process of evaporation and condensation. So, distillation, for example, purifying seawater. So as heat is applied, water evaporates and white crystal residues remain. Okay. So when we say distillation, diri na ma-involve ang process sa evaporation o condensation. For example, if ang usa ka seawater, ang usa ka purifying seawater, imo siyang iwad sa init. So, mukuan ang init nga ma-apply sa water, mo-evaporate siya. Ang mabili na lang niya katong mga white crystals or residues nga ma-remain, which is gitawag siya og salt. So it is one of the example of distillation. So next we have the another example, we have the alcohol in water. If i-mix din mo ang alcohol of water, kay mo-evaporate ang alcohol first, then ang mga water na lang mag-remain. So that is called distillation. Based on the examples, if ang usa ka substance i-mix mo sa water, then i-expose mo sa sun, mo-evaporate siya, which remains the residue, for example, sa purifying seawater, so mabili na lang niya ang salt. So kung ani ba this alcohol in water, evaporate ang alcohol, so ma-remain na lang niya ang water. Okay, next we have the filtration. So filtration is the process of separating filtrate from the residue by passing through the filter paper or strainer. So when we say filtration, it is a process wherein you separate nimo between ang usa ka substance sa usa ka substance. For example, coconut milk pass through the strainer while the coconut pulp or sapal and remain as residue. So dinhi kay if you do the process of filtration, you need to use the strainer or the filter paper. So through aning a process, ma-separate nimo, for example, sa coconut milk pulp or sa coconut milk niya o sa coconat pulp, mo siyang strain. So, faster sa strainer ang katong coconut milk. But ang coconut pulp, mag-remain siya as a residue or mo siya mabili. So it is called filtration. Or imo siyang gi-filtrate, gi-separate nimo ang separate nimo ang duha ka substances through through a strainer or filter. Okay, next we have the calamansi juice extract. So calamansi juice passes through while the seeds remain in the strainer. So in this process po, mag-use ta og strainer. So if ang calamansi juice nimo extract nimo kay naman siya mga seeds. So if ganahan ka, if you want to segregate the calamansi juice seeds niya. So you need to use the strainer. So pass through ang calamansi juice sa strainer while the seeds mag-remain siya as a residue. Ito siya sa strainer. Okay, another one, we have the muddy water. So water pass through the filter paper while the mud remains on the filter paper. So, ano you said, ang muddy water, if ang water, mo pass through siya sa filter paper. But, ang mga residue niya, like ang mud, mabili na siya, mag-remain siya. So, it is called filtration. Or gisala niyo. Salaon mo siya. Wala siya, duha ka, ang sa substance, kung imo siya i-filtrate, ma-separate siya. Ma-separate siya, na yung mga residue ng mga bili. So, next, since you said na you've learned for our lessons, so I'll give you 15 minutes to answer following questions already given. So all of these questions are related to the topic we discussed earlier. So there would be a 10 multiple choice questions and a 2 and a 2 is a question. So you will be given 15 minutes to answer. Okay, for your assignment, you will have to write any four purposes of classifying materials. So it could be for example, we have the helps identify safe versus harmful materials, or helps determine proper use, helps in recycling and waste management, helps in choosing materials for specific tasks. So you need to write any four purposes of the classifying materials. Okay, since you have already learned about our lessons today, so to end our lesson for today, let me share a simple but powerful quote with you. So, science begins with observations. So, what you see can lead to what you understand. So, everything we studied today, its pure substances, mixtures, and how to separate them, started with simple observations. So, by simply looking closely, noticing details, and asking questions, we were able to understand how materials behave. So when you go home later, so try to observe the things around you. From the food you eat, the drinks you prepare, the object you use, and try to ask yourself, is this a mixture or is it uniform? Can I separate it? Or the more you observe, because the more you observe, the more you learn. So keep your eyes curious, learners. So science is everywhere. So you just have to